Hey everyone, I'm Sanjay. Today I will be taking you through a 20 slide presentation on Database Management System or DBMS. We will explore what a DBMS and its structure, advantages, and many more key concepts that form the foundation of database system in the modern world. First, introduction of DBMS. A DBMS it is a software tool which helps in creating, managing, and interacting with the databases. Instead of manually handling large data files, DBMS allows user and programmers to access data in the more structured, efficient, and secure way. And next is characteristics of DBMS. Some main characteristics include data independence, meanings, changes in structure don't affect access. It also provides concurrent access, ensuring multiple users can work with the data simultaneously without conflict. Additionally, it ensures security and recovery in case of failure. And let's go to advantages of DBMS. The benefits are vast. It eliminates redundancy by storing data in centralized way, and also it means consistency across records and provides better integration of data from various departments. It also improves data sharing and enhance data security. Speaking about disadvantages, of course there are drawbacks. A DBMS can be costly and complex to set up. It may also require skilled personnel to manage it, and sometimes performance can suffer due to overhead of maintenance, consistency, and concurrency. And next is architecture of DBMS. There are three main architectures. One tier, where the DBMS and the application exist on the same machine. Two tier, where the client access the DB server directly, and three tier which introduce a middle application layer, improving stability and security. These are all the two tiers. And next is components of database and management system. A DBMS is made of several components. A query processor interrupts queries. The transaction manager ensures consistency. The storage manager handles physical storage, and the metadata catalog maintains definitions of the data. The next is data models in DBMS. Data models defines how data is structured. Common types include hierarchical, where data is organized like a tree. Network models that allows many to many relationships. Relation models using tables, and object oriented models combining DBMS with object programming. And next is relation data model. This model is most widely used. Data is stored in tables with rows representing records and columns as attributes. Key establish relationships, and SQL is used to manipulate the data efficiently. And the next is entity relationship model. The ER model helps in designing database. It includes entities, which is real world objects, and their attributes and relationships, etc. ER diagrams are translated into relation tables during implementation. And next is keys in DBMS. Keys are essential in database management system. A primary key uniquely identifies a record, and a foreign key maintains relationship between tables, and a candidate key are potential primary keys, while super keys include additional attributes beyond what's needed. And the next is normalization. Normalization structures a database to reduce redundancy and improve integrity. It involves dividing large tables into smaller ones and establishing links. It is easy to use. There are multiple forms: first normal form, second normal form, third normal form, and Boy's code normal form. First normal forms, it removes duplicates. Second normal forms focus on full dependency. Third normal form removes transitive dependency. And the Boy's code normal form are address anomalies. Boy's code normal form are also known as 3.5 normal form. SQL, structured query language. SQL is a language of database. It includes DDL to define structures, DML to manipulate data, DCL to control data, and TCL to manage transactions. Mastering SQL is a key to interacting with the relationship database. And the SQL is most easy language. Joins and subqueries. Join helps in combining rows from multiple tables based on relationships. Inner joins matches record. Left and right joins include unmatched rows, and full joins return all records. Subqueries are queries within queries, useful for complex filters. Transaction and concurrency control. A transaction is a group of operations that must all succeed or fail together. Database management system uses concurrency to control to ensure users don't interface with each other's work. Maintenance accuracy even when multiple transactions run simultaneously. And the ACID properties. ACID properties ensures reliable processing. Atomicity means a transaction is all or nothing. Consistency maintains rules. Isolation ensures transaction don't interface. Durability ensures data changes are permanent after a successful transaction. And the next is indexing. Indexes speed up data retrieval. Instead of scanning entire tables, an index helps the system find data faster. Common structures used include B minus trees and B plus trees. Indexes are crucial in optimizing larger databases. Next is file organization and storage. Data storage matters. Heap files store data without order. Sequential files sort data for faster retrieval. Hashed files uses a hash function for direct access. Choosing the right structure affects performance. The next is backup and recovery. Database management system offers mechanisms for data protection. Full backups copy everything. Incremental backups copy only changes. Differential backups copy changes since the last full backup. Recovery techniques like logs and shadow paging helps restore lost data. And the speaking about future of DBMS, the future is exiting. No SQL handles unstructured data. New SQL blends SQL with scalability. Cloud databases are becoming standard, and with AI and big data, DBMS systems are evolving to support smarter, faster, and decision making. If you had any doubt in this topic, just ask in comments.